on expanding logarithmic expressions. We have this nice condensed logarithmic expression, and we want to expand it out into sums and differences. Straight out of your book down here at the bottom, we have the properties that we use for logarithms. There's 3 properties that we're going to use. Okay, the first one is the product rule. It tells us, I'm going to come down here, anytime you have log of 2 things multiplied together, you can rewrite that as 2 separate logs, keep your base the same, as addition. Okay, so multiplication we can write as addition. The next rule is the quotient rule, and that tells us that when we have a log of 2 things that are divided, we can separate that into 2 separate things of subtraction. Okay, the first subtract the second. Or the top, anything on the top, subtract the bottom. One thing you want to notice, just some common errors, sometimes people forget to put the logs in there. Make sure you put the log there, or it doesn't work. And our last property is the power rule. And it's here, if you have it raised to a power, as we do in this example, notice we have u to the w power. It's log of u to the w power. You can bring the power down in front. Okay, so, and the reason for that is because, notice how they put the w right there in the front. It's because, remember, exponent tells you how many times you're multiplying something out. And so if this were to the 5th power, that means we have 5 of those, and it would be like 5 of them added together, or times 5. These are our basic rules that we're going to use. So what you want to look for when you're asked to expand, you want to look for any exponents, you want to look for any multiplication, or any division. Well, looking at this problem here, notice we have a to the 4th times b to the 3rd, log base 3 of that. Now, our rule tells us that when we have multiplication, we can separate that into 2 separate logs added together. Okay, multiplication goes with addition. The next thing that we notice now that we've separated, though, we want to simplify as much as possible. Notice that we have an exponent of 4 and an exponent of 3. Exponents can be brought down in front of the log. So we have 4 times log base 3 of a plus 3 times log base 3 of b. Okay? And this is as simplified as we can get it. We have no more exponents, we have no more multiplication, we have no more division, and we don't have any numbers that we could go ahead and find the logs of. So that would be our answer. Here is another example. And again, what we want to look for is any exponents, any division or multiplication, so that we can separate this out into separate logs. Notice this fraction here indicates division. We have x minus 1 divided by 64. So remember, division down here can be converted into separate logs that are subtracted. You always want to put the numerator to subtract the log of the denominator. Okay, so there you go. We've separated it out. Log base 4 of x minus 1 minus log base 4 of 64. Now we don't have any rules that allow us to simplify the log of x minus 1, so that's just going to have to stay. However, down here on the end, our log base 4 of 64, we can get an answer for that. In our last assignment, our job was to simplify without using a calculator. So remember, what logs tell us is we are asking ourselves 4 to what power equals 64 when we ask what log base 4 of 64 is. And it just so happens that 4 to the 3rd power is 64. So log base 4 of 64 is the same as 3. So our answer here, this is as simplified as we can get it, is log base 4 of x minus 1. It's very important to have those parentheses there. minus 3, because our log base 4 of 64 was 3. We have expanded it as much as we possibly can. All right, here's another one. Again, look for any powers, any division and multiplication. Now notice this one's a little different from the last time we had a power. The last time we had a power, it was inside the parentheses. This is outside, which means it's the y is squared and the 8 is squared. Okay, so the first thing we're going to do this time, we have to kind of like using order of operations. Since it's outside the parentheses, we're going to bring that down front first. So we'll have 2 times log base 2 of y divided by 8. Now we can still simplify because our rule down here says that if we have two things divided in a log, we can separate them into subtraction. So to do that, I'm going to put this in parentheses because that 2 went with the whole thing. So we have 2 times log base 2 of y minus, because division tells us to write as subtraction, log base 2 of 8. And we want to simplify that at all if we can. The log base 2 of y is simplified as it's going to get. Log base 2 of 8, where we just have numbers there, let's try to evaluate that. So remember, log base 2 of 8 is asking 2 to what power is equal to 8. And since 2 to the third power equals 8, log base 2 of 8 is 3. So we have 2 times log base 2 of y minus 3. Now let's just go ahead and distribute that 2 now to everything. And our answer is 2 log base 2 of y minus 6. And we're done. All right, next question. Again, we're just going to try to break this apart as much as we can. Notice that we have division, which we can rewrite as subtraction. So I have the natural log of x minus the natural log of the square root of y, again, because I changed that division, separated them into 2 separate with subtraction. We still have a power. Sometimes people don't notice the power because it's in a root, but remember the square root means the 1/2 power. So let me just rewrite this just a little bit so that it has the power there. We have ln x minus ln of y to the 1/2 power. And remember, our rule for the power rule is that we bring that down in front. So that's what I'm going to do. We have ln of x minus 1/2 the natural log, or ln of y. And that is as simplified as we can get it. Notice this time the 1/2, or my power, only went with the y value because the y value was only raised to that power, the x was not. So there's my answer. Okay, we're going to do, let's see, one more. This is the last example. So again, we want to look for any exponents, which notice we don't have necessarily an exponent written out, but we do have a root. It's a third root, I know by that little 3 there. And remember that roots are fraction powers. So this is ln of AB over CD to the 1/3 power, again, is what that little 3 outside my root means. I'm going to go ahead and drop the 1/3 down in front because the entire expression was the third root. And I get 1/3 times the natural log of AB over CD. Now anything on the top of the fraction indicates multiplication. Anything on the bottom of the fraction indicates it's being divided by that. So the top will be positive when I expand this out, and the bottom will be subtracting. Okay, so I'll have 1/3 of ln of A plus the natural log, or ln of B, minus those things that were on the bottom, the natural log of C, and minus the natural log of D, and because those were division. And then the only other thing I'm going to do is go ahead and distribute that 1/3 that I pulled down in front to each term. So I have 1/3 times the natural log of A plus 1/3 times the natural log of B minus 1/3 the natural log of C minus 1/3 times the natural log of D, and that is our expanded version of that expression above.